Here's part 2A4C3M1B7C8E13C9C6D3P38D19D7b9w. So this is line 22f1fa19c3m1b7c8e 13c9c6d3p38d19d7b9w. Radiative Atomic Spectra 5G Wow Seti. There's the alien radio signal. And this is radiation spectrum, visible light, long distance NIST Atomic Spectra Database, signal devices 2 in Wow's data formula, and it was made on March the 17th, 2013. Today's April 21st. So I googled radiative energy and spectroscopic data and found it in this previous line of video, split quarks mesons. We were talking about how to split quarks, and now we're going to talk about splitting mesons and other things. Sorry, I don't know what we're doing. Quote wiki, spectroscopy is the study of the interaction between matter and radiated energy. Historically, spectroscopy originated through the study of visible light dispersed according to its wavelength by a prism. Later, the concept was expanded greatly to comprise any interaction with radiative energy as a function of its wavelength or frequency. Spectroscopic data is often represented by a spectrum, a plot of the response of interest as a function of wavelength or frequency. So the key word is radiative energy. Radiant energy is the energy of electromagnetic waves. The quantity of radiant energy may be calculated by integrating radiant flux or power with respect to time. And like all forms of energy, its SI unit is the joule. The term is used particularly when radiation is emitted by a source into the surrounding environment. Radiant energy may be visible or invisible to the human eye. Radiative transfer is the physical phenomena of energy transfer in the form of electromagnetic radiation. The propagation of radiation through a medium is affected by absorption, emission, and scattering processes. The equation of radiative transfers describes these interactions mathematically. Equations of radiative transfer have application in a wide variety of subjects, including optics, astrophysics, atmospheric science, and remote sensing. Analytic solutions to the radiative transfer equation, RTE, exist for simple cases, but for more realistic media with complex multiple scattering effects, numerical methods are required. The present article is largely focused on the condition of radiative equilibrium. In climate science, radiative forcing is defined as the difference between radiant energy received by the Earth and energy radiated back to space. Typically, radiative forcing is quantified at the tropopause in the units of watts per square meter of Earth's surface. A positive forcing, more incoming energy, warms the system, while negative forcing, more outgoing energy, cools it. Causes of radiative forcing include changes in insolation, incident solar radiation, and concentrations of radiatively active gases and aerosols. Quotes, diagrams from blogs. This is www.nist.gov. NIST Home, PML, Physical Reference Data, Atomic Spectra Database, Version History and Citation Information. NIST Atomic Spectra Database. Version 5, welcome to the NIST Atomic Spectra Database, Standard Reference Database number 78. The spectroscopic data may be selected and displayed according to the wavelengths or energy levels by choosing one of the following options. Lines, spectral lines and associated energy levels, displayed in wavelength order with all selected spectra intermixed or in multiplet order. Transition probabilities for the lines are also displayed where available. Levels, energy levels of a particular atom or ion displayed in order of energy above the ground state. And then there's ground states and ionization energies of atoms and atomic ions. And that's at www.nist.gov. There's the contact information from the Atomic Spectroscopy group who wrote this. CL experimental wavelengths given with energy level classifications. EL experimental values for energy levels, and TP transition probabilities and or related quantities, oscillator strength, etc. That was on www.cfa.harvard.edu, and that's the link there, and the keyword radiative forcing will be in the next video. Thanks for watching.